All right. Okay, today we will actually continue with our lectures in topic related to the software design architecture. Before this, we already have the first phase of the software engineering. We call it requirement engineering. During the requirement engineering, we learned about a lot of theory and concept. What are the techniques should be used for the engineering as elicitations, the analysis, the evaluations, and so on. So after the requirement, meaning that we already reached, and somehow during the requirement, we already start some design, simple design. So in the topics of requirement engineering, we covered several things like use case diagram, some sort of sequence diagram, and so on. Actually, between the software and requirement engineering and the design architectures, we have a redundancy of some part of it, because during the requirement you might need some graphic, you might need some tabular format, you might need some illustrations or diagram to representing whatever you want to do or you want to actually implement in your software and so on. That's why I can say that most of the requirement engineering actually have a redundancy part for the software design and architecture. However, for these lectures, the learning objective is actually to understand why the architecture, the design is so important. Okay, why don't we cut down the time and directly go for the development? Why we want to actually take the horses into actually to have a design, considering what type of architectural design should be applicable or suitable for the software that you want to develop and so on. So that's why we want to learn why this is so important. What are the considerations or what are the things, the features or characteristics that we have to actually take into considerations before we decide what to design and what architecture patterns we want to use. Is there any application styles that we can follow and so on. So that's why it is actually very important. It's a learning objective for this topic. We have to learn what are the styles or common applications, architectures that can be used for actually for our design for the application. Okay, so that's why we want to learn what is the software architecture. Actually, when we talk about software architecture, is a whole design process. It's a whole design process that we want to actually identify what make up the system, what are the components inside the system, what are the subsystems should be inside the enterprise system, what will be the communications look like, what will be the control mechanism, what will be the layout for the software and so on. So basically, whole things here, we call it software architecture. We were going to actually name the whole output of it will be actually the design process, come out with the things, the product, we call it is the descriptions of the software architecture. So inside there, we have so many diagrams to representing what are the components, what will be the major layout, what will be the design, what will be the patterns that you use, and so on. Okay, so inside the architectural design, we're going to actually in the middle between, as I mentioned earlier, okay, requirement engineering and software or system design. So it's we call it a critical link between these two phases. So when you have the requirement engineering, you might use some graphical or tabular format in order to explain it to your clients, to the end users, and so on. And at the same time, before you actually, after you have a requirement engineering and validations, you are using some diagram in order to help you as a medium in order to validate whatever requirement from the clients that you are capturing correctly before you directly go for the detailed design and so on. So that's why it is actually very critical link. and you are going to identify the major components and their communications between the components. Okay, so you see it's a significant overlap. As I mentioned, it's a very significant overlap between these two phases. Okay, between these two phases. But actually, this is actually the things that we already bear in mind, because you are going to notice that in the topic 2, we actually have some topic related to the design diagram, and during the design and implementations, you have the topic of design again. So actually, it's a redundancy. It is a very significant redundancy. Is there anyone joining us? Wait, check. Ada orang nak join ke? Yes, okay. Hopefully okay dah kot eh. Back to my screen, can you see it?
Yes, Doctor.
Right, thank you for the response. Okay, when we design architecture, ada orang masuk lagi eh? I hope you can make it on time eh? Because when you're doing like this, you are going to disturb others. Okay, please make sure that next time, please make it on time. Okay, when we say it's 8:15, we're going to start. I already start to accept the students start for 8. Make sure that you actually enter the Google Meet on time. Kalau tak, you akan kacau lecture. Okay, please take notes eh. Okay, right, back to our slide. Okay, when we talk about architecture, somehow we have a terminology called abstraction. When we say this is abstract, macam you buat sesuatu paper, dia adalah first part of it will be abstract. Apa maksud dia abstract? Abstract is the things that telling exactly the overview for whole things that you want to write. That's why a paper abstract is very important. It should contain from the very beginning of introductions to the end of the conclusions. That's why whole thing so abstract tu adalah is just like an overview for the whole pictures of the papers and so on. Okay, if you write a paper, I don't know in which class you are going to write a paper. So the abstract is very important. It should cover from the very beginning of the introductions or background of study, then throughout the literature review methods and so on until we call it conclusion. So that means your abstract should include all this. Okay, is the overview. Same things go to the architectural abstraction. When we have an architectural abstraction, meaning that it's the abstractions cover the whole things, the whole environments or whole overview of that system and so on. So that's why we call it architecture abstraction. Okay, it's abstraction. Let's say diagram here. Okay, can you see what is actually the system? Can you name me the system? Kalau kat sini. I'm going to accept another one, I think. Okay, get back to our questions. Can anyone answer me? Try. Kalau tengok diagram yang ada kat sini, is architecture. Is architecture, but it's a very small scale of architecture. It's representing a system. What is this system? Anyone?
Medical system.
Medical system, okay, good try. Yang lain?
Training system, Doktor.
Pardon?
Training system.
Training.
Yes, sir.
Training system, yang lain? Tak tepat lagi. Tak tepat.
Doktor, LMS? LMS?
Learning management system. Learning management system, okay, tak tepat lagi.
Health diagnosis system.
Health diagnosis system. Okay, nearly nak tepat dah ni. But actually, anyone want to try out? Want to try out? Tengok dia punya basic features tu. Tak ada? Tak ada orang nak try?
Library punya
Okay.
ni.
Library. Alright.
Knowledge
What
base
is
kan?
the things that catch? Huh?
Sebab ada term knowledge base tu.
Actually what keyword that catch your eyes yang ada ni? Dia daripada siapa ke siapa?
Inference daripada doktor ke user.
It's an expert, correct? Dia tak mention doktor tu. You hanya influenced by gambar tu. You nampak adalah doktor. Dia
Consultation.
adalah
Expert system, doktor?
huh?
Expert system.
Correct. Expert system. Correct. So this is actually the basic structure for expert system. Tak kira lah expert tu siapa. Jadi itu adalah more kepada dia kata medical advice system, diagnosis system dan sebagainya. Disebabkan gambar doktor tu, gambar yang human expert tu, dia ada influence dia punya judgement. So actually the whole things here memang betul lah. Ini adalah untuk melibatkan untuk doctors, melibatkan medical field and so on. But the whole things here, the architectural abstractions here actually representing an expert system. Satu expert system. Expert tu regardless lah what type of human expert that you have. But if you want to design an expert system, let's say nanti later on in your or currently in your research methodology this semester, you want to choose a topic that related to expert system. Okay, is related to expert system. Maybe adalah expert dia adalah doctors, maybe expert dia adalah seorang pharmacist, maybe expert dia adalah seorang mechanic, maybe expert dia adalah seorang apa yang dalam certain fields and so on. So we call it human expert. Okay, so this is the expert system components. Apa yang perlu ada dalam satu expert system? It should have a human expert. That means you should contact with a human expert. Kena ada human expert. Bila macam tu, you actually react as a knowledge engineer. You have to capture the knowledge, okay? You have to put it into a knowledge base. Knowledge base, dia tak ada detail kat sini how you're going to do. No, it's only showing that what are the components. What are the components that you want to actually include and should include in an expert system. Maksud you kena build out knowledge base. You kena ada satu inference engine. And then you kena create satu user interface untuk deal dengan user. Okay, deal dengan user. So these are the components that should include in an expert system. Kalau you create satu expert system without any inference engine, dikira expert system tak? No, it's not called an expert system because you are not comply to the component that should be included in an expert system. Okay, so sini tak ada detail kata how you going to build your knowledge base. It's actually we are in the abstraction level. Maksud kita tak tahu in a very detailed part yet. Contoh inference engine, nak gunakan cara apa? It's not yet identified in this level. But you have to know in detail later on. Later on adalah untuk methodology, the methods in the detailed design of it, you should actually identify. Knowledge tak ada. You gunakan knowledge tu save kat mana? Katakan knowledge, you gunakan knowledge base ni, gunakan MySQL dan sebagainya. So bila macam tu, you kena ada inference engine. Inference engine adalah untuk macam mana you gunakan cara apa you nak inference kan tersebut. Guna fuzzy logic ke? Ataupun you nak gunakan cara rule base untuk inference ke? And then cara-cara dia, okay, inference engine tu. Maksud you build out the inference engine in order to connect the knowledge to come up with a decision. Okay, so this is an expert system to come up with the diagnosis, recommendations and so on. Okay, so these are the abstractions of architectures for an expert system. Okay, can you get it? Can you understand me? Boleh?
Boleh kot doktor.
Boleh doktor.
Boleh. So we are going to say that in this slide is going to say that we have architecture, but this is in a very small scale. Involve only actually very simple system. However, we have another type, we call it architecture in the large, meaning that it's a very complex enterprise system. Contohnya e-commerce system. Kalau you kata saya nak create satu enterprise system ni, bila you mentions about enterprise system, oh my god, actually it's so many subsystem and so many components, so many program inside there. It's an interconnection between subsystem components and all types of actually parts of program make up a whole complex system. So like for example this one. Okay, for example this one we have an e-commerce enterprise system. So dalam enterprise system ni bermaksud dia ada enterprise information system and dia akan communicate dengan banyak benda. So this one is an architectural abstraction in a large, meaning that it's a very large enterprise system. So it's actually make out there's a lot of subsystem and other components and program. Okay, that's why bila kita nak mula design, okay, as a actually when you start the design, you might not have some idea what should be inside the component and so on. It needs you to study. Okay, so it's very different when you are an experienced project manager ataupun you punya company dah ada some experience or documentations or design about certain system. That's why a lot of actually software house, especially some of the software house, is going to very focus on one area. Kalau dia adalah buat tentang klinik je, klinik management system, maka nanti selepas tu project semua dia akan berkaitan dengan klinik management system. Why? Because it can be reused. So abstractions, design, all the design diagram, all the things can be reused. Okay, can be reused and customized according to the current client needs and so on. But it's going actually to cut down a lot of time because they don't have to do the design from the scratch. They can actually reuse the architectural design. So that's why, what is the advantages when we have a very clear or explicit architectures? Okay, number one is to ease the stakeholder communications. That will be our medium to discuss with our stakeholders. Kita akan bagi satu high level punya abstraction macam tadi. Okay, so kita akan tunjuk diagram tersebut supaya kita boleh fokus on the discussions, what to discuss, what should be included, what should be excluded, what will be in your budget, and what are the things that you were going to actually include in the later developments and so on. Okay, number one. Number two is actually to ease the system analysis. When we have early architectures like this, is actually to ease the analysis to identify what type of non-functional requirement we want to emphasize. Is that we want to emphasize on the performance? Is that we want to emphasize on the reliability? Is that we want to emphasize on the maintainability? So these kinds of non-functional requirement is going to influence our design decision. Kalau sesuatu design decision, kalau katakan dia kata saya nak sesuatu yang melibatkan performance, saya nak saya punya application nanti adalah in terms of performance, saya nak TikTok. When we call about the performance, meaning that when we design it, we have to design in a very large grain of component. Satu komponen dengan satu komponen tu jangan besar, jangan too small components tu. Bila small component, dia melibatkan dia communication banyak. Bila is a large grain of component, is going to actually to shortens the communication between component and component. Is going to actually have a quite high performance dan sebagainya. So that's why it's very is a very initial area for us, initial step for us to identify the non-functional requirement. Okay. And then last is actually the large scale reuse, as I mentioned to you. Okay, most of the software house, especially software house in Malaysia, saya dah nampak lah dia dah more focus kepada whatever area that related to their the experience of development untuk reuse of the architecture, of the design, of what type of requirements and so on. Okay, is going to actually shorten the time for the development, and is going to actually can fulfill have experience to fulfill the client needs better. Okay, it's a large scale of reuse. Okay, so when we want to actually represent it, just now we talk about back to aspect system just now. It's a simple informal block diagram. It's a very simple informal block diagram to show what will be the entity and the relationship between the system and so on. However, these kinds of box and line actually is lack of semantic, meaning that it's lack of, do not show what types of relationship between the entity, and the most important things, they didn't show any properties. Meaning that just now knowledge base, ada tak dia tunjuk dalam tu detail apa? No, it don't shows the detail of it. Or just now inference engine, how inference engine is going to actually implement it is not clear enough for the simple and informal block diagram. However, these kinds of diagram is still very popular. It's still very popular to show what? To show the basic entity and component should be inside the system that you want to develop. And it's actually is a very, we call it is a very simple diagram that everyone can understand. Even your client is not in the field of computer science is going to understand it. Okay, itu yang kami buat untuk medical doctors, itu yang kami buat untuk pharmacist dan sebagainya. Supaya dia orang bukan dalam field computer science, but if we draw it in a very simple informal block diagram, like for example this one, is very abstract. It's very abstract. Memang disadvantage dia sebagai abstract, but very useful in terms of communication, to show the flow, to capture what are the flows and so on, and is to ease for the especially the non-computer science background expert or non-computer science background client to understand the whole things, the overview for the whole system and so on. So that's why this one is a very simple example, but everyone can understand it. Of course lah, memang ada disadvantage because it is too abstract. Didn't tell the detail how you're going to implement, let's say the packaging selection system. Macam mana dia nak select? Ada tak dia tengok packaging tu adalah ikut size ke untuk mula package dan sebagainya. So it's a packing robot control system. Contohlah sekarang ni ada banyak yang adalah online. Oh, getting ready for 11/11. Contohlah Lazada dan sebagainya. So actually if they come up with a packaging robot control system, dia dah nampak, okay, virtual system nampak packaging berapa banyak and then macam mana objek dia identified dan sebagainya, dia mula buat packaging selection dan sebagainya. So apabila dapat je packaging size macam mana, dia akan mula salurkan ke controller mana dan sebagainya untuk dia lipat, untuk dia bungkus. Kalau boleh buat dalam keadaan yang robotik macam tu, whole packaging akan dah laju. Maksud walaupun order mungkin banyak, but if you do it is a robotic, is an intelligent robotics and have a virtual system in order to control all of it, insyaAllah kita dapat package tu ramai, cepat. Okay, so I think everyone just like me waiting for 11/11. Saya tak tahulah you channel apa nak beli, tapi my channel will be Shopee. Saya dah banyak lah letak dalam cart. Ada orang letak dalam cart tak? Dah mula letak dalam cart?
Ada doktor.
Ha?
Ada.
Ada oh, bukan saya je lah ya, saya pun normal person juga lah maksud dia. Cuma saya tak berapa prefer Lazada lah. Lazada memang ada banyak choice and then dia buat promotion besar-besaran. But I'm not a user of Lazada. I have bad experience about Lazada. So now saya punya tempat adalah Shopee. So that's why banyak lah letak dalam cart. So dalam cart rasa saya ada 25 benda lah kot. Bukan saya alone my daughters and so on all put it inside. So that's why if we can actually do it is a very quick way and so on, it's going to ease the deliver system and so on. So ini buat kat mana tahu? China memang dia adalah whatever yang you nak beli dan sebagainya, you akan hantar kepada dia punya sorting center. Sorting center dah mula letak and deliver ke negara mana dan sebagainya. Semua gunakan robot. If you have you boleh Google dalam YouTube lah how China doing it. Okay, how the whole system of China doing it, memang dia very quickly. Okay, Taobao saya tak tahulah sesiapa pernah dengar tak? Taobao pernah dengar? Dia macam Shopee. Benar kan? Tapi memang dia adalah large scale gunakan intelligent system, gunakan robotik dan sebagainya. Memang very quickly dia punya tu memang ikut yang apa packaging robot ni. Memang dia laju. Semua akan hantar ke negara mana dia cover whole world So dia akan hantar ke negara mana dan sebagainya untuk shipping dan sebagainya. Memang dia buat cara macam tu. So that's why walaupun ambil masa kadang-kadang Taobao ni saya ambil masa dalam sebulan, ada yang sebulan setengah baru sampai. Tapi barang tu terlampau murah. And then kita boleh jadi peniaga kot. Kalau saya tak jadi lecturer nanti boleh jadi peniaga kot. Okay. So that is the things So kalau Malaysia boleh buat macam tu memang heaven lah. Memang heaven untuk semua kita punya barang-barang dan sebagainya. Alright. So again this one I think it's already covered. So the architecture is used for facilitate the discussions. Okay. And also we are actually is a way of documentations, if one part of the documentations. So when we want to make a decision, is two things that we want to actually identify is actually the functional and non-functional system requirement. Okay, so what are the questions that we want to ask in order to actually to decide on the architectural design? Number one, when you have a project, ask yourself, is there any generic application architecture? Contoh kalau you nak buat adalah satu expert system. Seorang doktor reach to you or seorang pharmacist reach to you or any of the expert reach to you. I would like to actually to create a knowledge system, a knowledge representation system in order to represent whatever knowledge I have. So you have to bear in mind, kalau dia adalah seorang expert, then you can use the system expert punya generic application architecture. You akan guna expert system punya architecture sebagai application architecture yang ada. So that's why you actually ask yourself the first question, is there any generic application? Kalau ada, please have a study of it, what will be component inside dan sebagainya. Because some of the expert or most of the expert is not computer savvy. That's why dia tak tahu pun apa yang perlu ada dalam sistem tersebut. So is your task actually to find out, is there any generic one? If there is a generic application architecture, what type of application architecture is that? Okay, so once you dapat contoh expert system tadi tu, dapat je expert system, you tanya-tanya, okay, client, you nak system tu stand alone ke distributed? Kalau dia kata stand alone, then that will be definitely different types of architecture. When dia kata saya nak distributed, saya punya klinik dia akan ada banyak cawangan yang ada, saya nak adalah distributed. Saya ada 4 cawangan kat Selangor ni, saya nak distributed. When it is distributed, that means inside your mind you have to know that dia akan go for client server. Bermaksud client server architecture paling sesuai disebabkan dia distributed. Okay, when you say is architecture style tadi tu this architecture style is related to question number 2. So bermaksud dia akan guna client server. Client server support you kena adalah create hardware tu, bermaksud dia kena ada server. Ada server and then dia adalah client kepada banyak, ada server kena ada satu tempat lah. And then bermaksud you kena cater untuk hosting, cater itu adalah technical part. Bermaksud apa architecture style yang you boleh guna adalah client server. Okay, client server architecture. That will be the architectural styles yang ada. Then what type of approach that you want to use to structure the system? What type of approach itu adalah dalam detail lah. So you nak gunakan approach apa untuk jadikan dia punya detail parts of it. Inference engine dia macam mana, decomposition dia macam mana you pecahkan knowledge base tersebut, ada tak satu knowledge saja ataupun dia banyak benda. That's why is adalah decomposition diagram yang ada. Macam mana how the system is going to break into small pieces. Okay, small pieces of small program or small subsystem and so on. So what are the control strategy? So apabila kepada access you letak kepada server, mesti ada control strategy. How you control the access, okay? How you control the usage of the system. How you're going to actually have a mechanism in order to monitor the log, okay? The log, the system log. Siapa log in, siapa buat apa dan sebagainya. The system trail dan sebagainya. You kena design on the control strategy. And then in terms of non-functional tu bermaksud apa yang diperlukan. Ada the availability. Kalau availability lain. Kalau dia kata dia nak, saya lepas ni saya ada in-house maintenance, then dia more emphasize on the maintainability. Cara design dia akan lain. Kalau dia kata okay, saya adalah nak kepada performance, cara dia design lain. That's why you have to actually, these are the some simple questions that have to ask yourself before you decide what kind of architecture should suitable for the client, for your user. Okay, how is going to evaluate it? Bila you tahu adalah non-functional tu apa, baru you ada evaluation matrix ya. Okay, kalau performance evaluation matrix dia lain. Contoh how many millisecond untuk satu transaction yang ada. So itu adalah, it depends on the non-functional, how you're going to evaluate it and so on. So and then documentation of course. Okay. So as I mentioned to you, this is the architecture reuse, can be reused. We have a few application architecture. Maybe tadi you akan tanya, apa maksud dia application architecture? Contoh yang saya bagi tadi itu adalah expert system. Selain daripada itu, kita ada data processing system. Kalau data processing system, bentuk dia lain. Transaction processing system, bentuk dia lain. Event processing system, bentuk dia lain. Language processing, bentuk lain. Maksud, all kinds of architecture, we call it adalah application architecture, meaning that if you choose any of the processing system yang listed kat sini, dia ada certain styles dengan patterns dia. Okay, that's why kita boleh follow lah. Just like you are building a house, okay, you are building we call it let's say kalau dia punya, you punya cara nak build adalah satu apartment. Apartment dia ada blueprint dia ada lain. Dia punya design dia lain. Kalau you kata okay, saya nak buat satu bungalow, okay, dia punya drawing dia lain. Kalau you kata you nak buat satu adalah link house, okay, lain. Dia punya design dia lain. Same go to the architectures of applications ni. Okay, application architecture ni. Maksud kalau you nak build sesuatu yang berkaitan dengan bidang tertentu, dia akan bentuk dia akan berlainan. Okay, I would like to take questions. Any questions so far? Ada soalan tak? Is that going too fast? Saya laju sangat tak? Can you follow?
Boleh follow. Boleh follow doktor.
Boleh follow. Okay. So that's why this is we call it architecture styles yang ada. Ada certain pattern how you organize the whole system. We have a generic architecture of it. Bermaksud kalau you nak buat sesuatu, dia mesti ada generic architecture. So these are actually the knowledge that you have to know, the knowledge that you have to equip yourself okay, before you enter your actually the project, okay, the project for the master's level dan sebagainya. Because at the end you are going to actually produce something. Produce something meaning that is actually a prototype that that proof is a proof of concept for whatever you want to design so on. So that's why you have to know that what will be the generic architectures that are available, okay, to simplify your design, okay. But in reality, kalau katakan melibatkan large system outside here, we have a large system. Most of the system actually didn't follow just a single architecture because it's actually using some or more architecture combined. That's why kita namakan heterogeneous, meaning that we actually combining not a single architecture, however is a composite architecture. Okay, contoh macam tadi lah client server. Bila you kepada client server tu bermaksud you ada client, ada network, ada server. So itu adalah untuk distributed. But one of the companies saying that my data is so important, I would like to actually have a data centric. Bermaksud satu data kumpulkan satu tempat. Bermaksud you kena consider gunakan repository inside the client server. Meaning that dalam client server, when it reach to the data, you are going to use the data repository. It's a combination of client server with the repository architecture. So it might need you to think, okay, to use more than one architecture that going to cover in the in these topics. Okay, so again, the selections here, these are some of the non-functional requirement. Okay, as I mentioned to you, when this client say, I would like to have a performance, bagus punya lah, dia kira performance bagus punya system. So when we have a performance, emphasizing on the performance, meaning that you have to use a large grain of the components rather than the fine grain, because it will going to reduce the components communications. Okay, in component with component, kalau you banyak kecil-kecil maksud satu pass parameter kepada satu lagi, satu pass parameter kepada satu lagi dan sebagainya. So parameter passing the parameter. Kalau terlampau kecil, maka communication dia banyak. So akan slow down the system. So that's why when you want to design it and the user saying that I would like to emphasize on the performance, meaning that you have to program it parameter passing untuk satu komponen, you're going to reduce it. So that is going to actually have, can reach to the performance, high performance. Okay, because you are going to reduce the communications between the component with the component. But when we talk about, macam tadi tu dia kata, oh saya perlukan untuk security, especially contoh melibatkan military punya sistem, maka dia kena guna pakai layer architecture. Why layered? Kerana layer ada user interface sebelum masuk ke authentication, masuk kepada application layer, termasuk kepada business logic layer, kemudian baru kepada database layer dan sebagainya. So it's actually, it needs the user in order to get the innermost critical asset database tu, dia kena punch through the layer. Maksud that will be the consideration. You akan gunakan layered architecture. Okay, layer architecture and used to secure the critical asset, that is your database, sensitive data punya database inside in the innermost layer. Okay, that will be the consideration. But if you say you are emphasizing on the safety critical, when we call is a safety critical, that you have to actually put it in a smaller subsystem. Bermaksud you kena letakkan dia located in a single system or subsystem untuk kita nak ensurekan safety of that components and so on. Another one adalah availability. When we talk about you want to make the system available 24/7 and so on, make sure that you have to use here is actually is a client server. Bila client server, maksud dia you ada redundant component. Sini pun ada satu, situ pun ada satu, sini pun ada backup. That's why you ada backup system, and then you kena after, kalau katakan satu system shut down, then the backup system will be activated untuk nak jadikan availability. But when it is availability, redundant lah komponen. Kerana you simpan satu kat backup server, simpan satu kat live server dan sebagainya. So that will be the redundant component. When it is a redundant component, meaning that it's a costly lah. Duit akan spend banyak disebabkan you kena ada redundancy components, okay, inside the system. Lastly, you can actually, as an example here, it's not limited to here. However, these are some examples of the non-functional requirement. When the company saying that, or as a government agency, dia kata lepas ni in-house saya nak maintain ni. When you know that the client intentions of the system after you deliver to them, they want to maintain it internally or in-house, maka you kena design it is a very fine grain, bermaksud self-contained. Kecil. Bila kecil tu senang dia nak maintain lah. Contoh data ni habis, dia akan pass kepada data ni. Komponen ni habis, dia akan pass kepada komponen ni dan sebagainya. So akan jadi small grain lah. Untuk senang dia nak maintain. Ini ada problem, dia betulkan ini. Ini ada problem, dia betulkan ini. Senang dia nak faham. Kalau tak you longgokkan satu program besar dalam big component, nanti dia susah, dia nak maintain dan sebagainya. Okay, so it's actually maintainability. Then when you talk about maintainability, then repository is not suitable. Repository architectural style is not suitable. Okay, it's not suitable for the maintainability. Okay, so in terms of this, we have some conflict. Okay, you kata semua non-functional ni ada kebaikan, keburukan dia dan sebagainya. But in the reality, when we want to emphasize one or more, it's actually very difficult. Just like your client say, saya nak actually in terms of the performance, saya nak performance juga and at the same time saya nak maintain. Boleh tak? It's a very difficult. Why? Once you kata, contoh kat sini, performance dengan maintainability, let's say. When you say is a performance, bermaksud you kena design it as a large grant. But at the same time, company tu kata, agency tu kata, saya nak maintain ni nanti. Boleh tak? Tak boleh dua-dua at the same time. Because when you want to maintain it, it's better for them to have a fine grain, kecil. Komponen yang kecil-kecil supaya dia senang maintain. But apabila komponen kecil-kecil tu, communication akan banyak. Once communication banyak, bermaksud performance akan turun. So this is actually, we call it is architectural conflict of it. Okay, we cannot make it too...
Doktor, apa maksud large grain components and small grain components?
Okay.
Komponen tu dari segi apa?
Okay, kalau you tulis program, ini adalah more technical part lah untuk design and implementation topik ni. Contoh apabila you nak design sesuatu adalah contoh you data process, okay, mungkin you akan buat data processing system. Apabila data processing system adalah komponen untuk terima data saja. Terima data saja, selepas proses data tersebut dia akan pass kepada another component. Okay, dia akan jadikan macam parameter lah. Parameter dia akan pass kepada another component. Another component akan process it. Lepas tu dia akan pada komponen-komponen kecil-kecil kan. Once komponen kecil-kecil ataupun modul lah kecil-kecil. So bermaksud you akan passing parameters. Once you passing parameters tu, bermaksud performance akan rendah disebabkan dia ambil masa untuk nak passing. Compare dengan you longgokkan satu benda tu, bermaksud data processing dan sebagainya, satu komponen, lepas tu apabila sampai display satu komponen. Jadi dua komponen. Maka communication hanya adalah dua komponen. Maka performance dia lebih tinggi. But in terms of maintainability, orang yang nak maintain nanti, dia nak cari dalam dalam satu komponen yang besar tu, dia banyak sub-program dalam tu. Maka dia susah dia nak maintain benda tu. So that's why itu yang nama dia large grain dengan fine grain tu. Maksud large component dengan small component. Boleh faham ke? Bermaksud program tersebut. Yes.
Dari segi in terms of the codes lah.
Betul. In terms of the codes. In terms of the implementation nanti. Kalau kita design ni, kita pecahkan design ni adalah satu benda yang besar saja. Apabila masa sampai ke technical team, implementation team tu, dia kata okay, ini adalah bahagiannya, dia hanya design satu yang besar cukup untuk mewakili untuk contoh tadi untuk selection, packaging selection system. Dia hanya jadikan satu komponen besar. If you design it very detailed part, maksud dalam design tu ada lagi kecil-kecil dan sebagainya, then apabila orang yang dapat drawing tersebut ataupun design tersebut, dia tahu okay, sistem analis dia dah dapat information daripada klien di mana klien akan design adalah nak untuk kepada contoh nak kepada performance. Maka dia akan longgokkan dia dalam satu komponen yang besar. System by system dia akan passing. So it's actually on the technical part of it lah. Okay, in the writing of the technical part of it. Boleh ke? Is that clear?
Yes, Doctor.
Alright, okay. So same things go to availability and security. When we call availability, tadi availability apa? Availability tadi adalah untuk di mana availability adalah redundant. Maksud kat sini location satu, location A ada satu, location B ada satu, location C ada satu. Apabila dia ada banyak, okay, redundancy. Maksud server A down ada server B down ada server C dan sebagainya. Memang apabila you ada redundant komponen kat different server dan sebagainya, availability memang TikTok. Bermaksud server A down, you ada server B down, you ada server C dan sebagainya. But availability memang bagus lah. But when you say availability banyak, then in terms of actually it's going to actually conflict with a security. Why? You kena banyak lah, bermaksud selain daripada server A, you kena buat firewall, server B buat firewall, server C dan sebagainya. In terms of security, it will make it very difficult and costly. Maksud you kena banyak tempat you nak secure. Disebabkan you dah banyak komponen yang penting kat beberapa tempat yang berbeza. So that's why it's actually, we call it architectural conflict. Kadang-kadang you tak boleh janjikan benda yang memang it's not possible to have at the same time. Okay. Contoh yang satu lagi adalah localizing the safety features. Localizing the safety features bermaksud you kena localize, so bermaksud you kena letak dia dalam satu single komponen, kena komponen kecil lah, komponen kecil. But bila komponen kecil macam saya kata tu akan influence kepada performance. Dia tak boleh sekali. Contoh safety features tu adalah melibatkan military system. Melibatkan dia punya data weapon dan sebagainya. Data tentang military forces, armed forces dan sebagainya. So bila macam tu dia akan letak kat innermost. Bila innermost dia gunakan layer lah, dia kena punch through, punch through sampai login je kepada sistem login je, dia akan authentication application punya authentication lagi, database punya authentication lagi, semua baru sampai ke innermost tu. Bila macam tu performance wise susah lah. Bermaksud you akan ambil masa lama untuk ni dapatkan innermost punya the safety features yang ada tu. So that's why sesiapa yang melibatkan untuk military system dan sebagainya, dia dah tahu dah. You kena tahu adalah kalau you nak secure you punya ni, then that means in terms of performance you kena give out lah. In terms of good performance, you kena tahu login dalam sistem tersebut je asking you for authentication. Masuk ke application level dia kena authentication sekali lagi. Masuk je ke database level dia kena authentication sekali lagi. Nak download file dia ada authentication sekali lagi dan sebagainya. So in terms of the performance is going to actually cannot be actually created at the same times. Faham So these are some conflict lah. These are some conflict that we have to know. Kita tak boleh janjikan sesuatu, you nak maintenance, boleh. Performance, boleh, tak ada masalah. But we don't know that it cannot actually have it at the same time. Memang very very impossible to have it at the same time. But bila you tak ada knowledge, you janji dengan klien tu semua boleh. Boleh tak? Boleh, no problem. Boleh, no problem. But you don't have that knowledge of it. So that's why it's actually build out your knowledge. Certain things cannot have it at the same time. You have to let your client know about it, the facts of it. Okay, any questions so far?
No, Doctor.
Okay. I proceed with this one. This one saya rasa saya very quickly go through disebabkan ini dah cover during previous lecture. So we have a lot of actually view. We have different perspective, different view of architecture. So paling terkenal adalah 4+1. Kalau you pernah guna star UML, white star UML ataupun any UML, software, we going to actually have pada perspektif dia ada 4+1 view. 4+1 view ni membolehkan you buat logical view, membolehkan you buat process view, melibatkan you buat development view dengan physical view dan sebagainya. So when we talk about logical view, macam tadi itulah key abstraction adalah object dengan object. Bila kepada process view, dia more kepada interactions in between the process. Okay, we have maybe we have sequence, we can have stack diagram and so on. In terms of development view tu adalah how you're going to actually have a decompositions of module. Maksud dalam tu maybe you adalah class diagram in order to represent it, atau melibatkan database you ada ERD diagram, okay, entity relationship diagram in order to represent the development view and so on. And then in the physical view, it's going to show what type of hardware is going to use, software is going to use, how you're going to distribute it, how the shared data is located and so on. How it's going to secure for the whole system. Benda-benda macam ni adalah physical view. Lastly, +1 here is scenario. Maksud selain daripada you bagi sesuatu diagram, you come up dengan scenario. How the user use it. Okay, how the user use it. What were the normal flow of it, what will be the exception flow of it, what will be the expected output, what will be the things that actually the things actually when it goes wrong, apa yang akan jadi dan sebagainya, exception flow tu lah. Okay, that will be the use case dengan scenario +1. Okay, So directly this one saya rasa saya pun skip yang ni, kot ini tak berapa, ini saya bukan tak berapa penting. Dah cover last week untuk semua modul yang ada. Okay, I direct go for the architecture patterns. When we have architecture patterns, adalah kita masuk dia patterns ni, we can actually representing what will be the styles or distinctions of the design of architecture. So we can represent the software or architecture's patterns into two formats. One is a tabular format, the other one will be the graphical notations. That is a graphical description. Kita boleh create two types of representations. For example, we have MVC, Model View Controller. So most of you actually learn it during your degree. Okay, Model View Controller. When we have a Model View Controller, you kena tahu adalah you create software. Contohlah you gunakan paling basic untuk Java. Paling basic untuk Java, selain daripada you create it as actually whole program, whole system tu dalam satu folder. Semua tulis dalam tu. Okay. But actually you can organize it into three main folder. Model, View, Controller. So if you organize it nicely, this will be the patterns of it. Okay, pattern of it. Kalau you kata, saya follow MVC ni. Bila you follow MVC, open your system or open to the code, you ada nampak adalah memang ada organize dalam 3 folder yang berbeza. Model, View dengan Controller. So when we have a model, view dengan controller, when we have these kinds, when we want to use it, when we have a multiple way to view with the data. Contoh client user jenis A masuk, dia akan view dia lain. Jenis B masuk, view dia lain. Jenis C masuk, view dia lain. Contohnya apa? Contoh kalau saya adalah lecturers, saya akan view you future cara lain. And then you sebagai student masuk you future, you akan nampak view dia lain. Satu lagi adalah sebagai admin, dia akan masuk you future, view dia lain dan sebagainya. Kalau saya sebagai resource person, saya masuk you future, bentuk dia lain. Bermaksud bila macam tu, boleh tak you future design dengan MVC? Boleh, tak ada masalah. Because we have a different or multiple way of view to interact with the data based in the you future. So that's why it can implement MVC. Okay, if I implement MVC. When we use MVC, what will be the advantage of it? Is going to actually to allow the data to change independently. Okay, independently. That means kita tak tied dengan view dan sebagainya. And we can have different types of view or presentations of the same data. Data tu akan keluar dalam tempat yang data dia sama, but how we're going to display it, well, it depends on the presentation, depends on the view, and depends on the type of user. Okay, that is the major advantage of MVC. Okay, that's why sekarang ni dia dah kalau sesiapa pernah come across kita adalah MNVC ada untuk mobile model view controller. Okay, untuk kita extend kepada mobile application. Okay, disadvantages of it bermaksud you kena additional code lah, code complexity dan sebagainya. Bermaksud you kena extra job untuk nak differentiate it dalam model, dalam view, dalam controller. So that's why it's actually in terms of code memang very tedious. Okay, so in terms of the tabulate, okay, kita boleh represent sesuatu pattern gunakan tabulate format. Another one is using the graphical notation. Bermaksud kalau you kata you gunakan MVC, saya punya website nanti gunakan MVC. Bermaksud kalau you kata MVC, okay, you punya examiner akan check 3 komponen penting. You kena ada controller, you kena ada view, you kena ada model. Okay, so bermaksud you ada model MVC lah yang punya pattern kat sini. So where we pattern have here, okay, we have some change request, we have a change notification, we have a user event, we have the view selection dan sebagainya. So bila kita kata kita follow MVC, let's say contoh ni, okay, satu web application using MVC, nampak tak dia punya pattern dia sama. You ada model, ada view, ada controller. Maka you nak draw architecture tu kena follow the pattern. Okay? You ada model, ada view, ada controller. Hantar sesuatu contoh you ada view, okay, view user event adalah type untuk HTTP request. When you adalah HTTP request, ya update request, model dia akan dapat, okay, apa yang perlu keluar dan sebagainya. Dia akan change notification. Okay, so and then dia katakan dia gunakan certain form ataupun dia nak gunakan validation, data validation. Dia akan request for data validation. Maka controller akan proses untuk data validation, send to the request. Request dalam model tu adalah validate data, update data, update profile dan sebagainya. Then dia baru akan change notifications and so on. Okay, this one Facebook. For example lah, this one Facebook. Dia gunakan MVC. Okay, dia gunakan MVC. So katakan kita ada view. User event tu katakan dia adalah edit profile. So dia hantar request, user event hantar request untuk edit profile dia. Maka dia akan update, controller akan hantar request untuk kepada model. Model akan update kepada profile yang ada and then dia akan balik notification kepada user kata dah change dia punya profile. Katakan dia nak add status, user event hantar add status kepada controller. Controller akan update request kepada model, model akan update status and dia akan hantar notification. Benda ni you akan rasa lecehnya. Of course lah, tadi pun kata disadvantage adalah melibatkan code complexity. Dia akan passing. But it's actually, what is a good thing? Anything relate to the model, saya boleh ubah kat model saja. Contoh, saya boleh letak kat model tu person, update status, comment dan sebagainya, saya boleh tambah kat situ. Boleh tambah kat situ, that will be different view. Okay, so siapa masuk, dia akan jadi different view of it. Okay. So dia tak kacau kepada view, tak kacau kepada controller, saya hanya modify kepada model. Kat folder tersebut, kat file tersebut untuk saya update. Okay? Is that okay? Now you akan nampak pattern ni sama Maksud ini akan gunakan MVC. So these are some example Boleh The first one.
Balik through ke? 08
Okay, so the layer architectures here, the first, the next one adalah layer architecture. When we have a layer architecture, okay, is support, paling penting adalah support incremental development. Meaning that if you want to emphasize on the incremental development, contoh saya nak buat sikit, then you can consider layered architecture. Ataupun you nak jadikan sesuatu masuk sesuatu penambahan kepada sesuatu function, sesuatu layered dan sebagainya. Then you boleh gunakan dia sebagai layered architecture. So let's have a look at the descriptions of it. You organize the system into layered with the related functionality in each layer. Contoh adalah user interface layer. Semua user interface layer adalah content user interface lah. And then you adalah kepada kepada layer dia adalah application layer. Maka application layer tu application layer lah. Masuk kepada business logic layer, masuk kepada database layer, operating system layer dan sebagainya. So actually you organize it into layers. So a layer provides service to the layer before it, above it, so that the lowest level of layer represent the core services. Masuk dalam tu, outside layer akan jadikan dia punya user interface very common, authentication dan sebagainya. But the core business will be in the layer 3 or layer 4. Biasalah layer number 3 ataupun layer number 4 adalah core business. Masuk core services. Okay, core services. Nanti kita tengok contoh yang ada. So what are the advantage of it? Allow you to replace the entire layer. As long as the interface, bermaksud you nak calling, interface dia comply, then you boleh call the dia punya another layer and so on. So and then in practice, disadvantages is actually logically saying that is clear separations between the layer is quite difficult for you to do. Okay. However, and another disadvantage of it, as I mentioned earlier, performance-wise. Maksud kalau you gunakan layered, you are going to forget about performance because when it is a layered, you boleh capai kepada safety. Safety bermaksud when you want to have safety features adalah database you nak katakan saya punya data tu very sensitive data, in terms of privacy user saya kena jaga, in terms of some important data saya tak boleh leak dan sebagainya, you confirm you akan gunakan layered. However, using the layered in terms of performance memang akan susah disebabkan user have to punch through all the layered in order to get the data or even download a file. Okay, even download a data. Okay, so this is the generic. Tadi itu adalah pattern dalam tabulate. This is a generic. When you talk about layer architecture, dalam you punya mind tu macam kayak lapis lah. Maksud dia kena lapisan. First layer user interface layer. Second layer adalah user interface management. Maksud apa yang user interface, dia akan communicate dengan user interface punya management dulu. Okay. Kebiasaan kat layer ni adalah termasuklah authentication, authorization dan sebagainya. Okay. Bila macam tu dia akan masuk kepada satu layer lagi. Satu layer sama ada satu ataupun dua layer tu adalah untuk core business layer. Core business layer tu bermaksud functionality. Okay, dalam layer tersebut, layer ketiga kat sini, kebiasaan adalah functionality. Apa function yang ada dalam you punya application tu adalah dalam layer ni. Maksud layer ni contain apa? Core business layer. Okay, core business layer, apa service yang you boleh provide, apa functionality yang you boleh bagi dalam sistem adalah semua dalam layer ni. Kemudian baru kepada operation system layer ataupun database layer. We call it system support layer. These are generic, a generic layer architecture. Okay. Kalau katakan nantilah, kalau katakan final assessment, suruh you design, you gunakan design layer architecture. Make sure that you comply lah. Kalau saya, kerana soalan dia akan open. Tak kira you gunakan design apa. Kalau you kata saya nak design based on apa senario yang saya bagi nanti, you kata you nak design gunakan layered architecture. Make sure that you follow the layer architecture tu. Kalau you kata you nak design gunakan MVC, then you follow lah MVC tu. So bermaksud you kena follow dia punya design architecture tu. Okay. So these are some example. Okay. Ini adalah library system. You ada satu web browser interface. Bermaksud contoh Pita. Pita ada interface dia, web browser interface. Bila web browser interface, dalam interface dia yang luar tu, dia ada satu nama dia authentication atau kita namakan user interface management. Perlukan you untuk login, boleh you buat request query, boleh you kepada print, boleh apa, semua adalah untuk user interface management layer. Masuk ke dalam sikit adalah core business layer. So ini adalah dua, okay, ada dua. Satu core business layer tu bermaksud library system ni boleh buat apa? Dia boleh buat search, dia boleh buat document retrieval, dia boleh buat untuk apa yang register untuk copyright dan sebagainya. Dia boleh membolehkan library buat untuk accounting layer. Bermaksud accounting, bermaksud denda ke fine kepada siapa yang tak refine buku dalam time frames ke dan sebagainya. Ataupun sales. Okay, library kan ada buku, kemungkinan dia akan buat sales, kemungkinan dia akan yang buat interlibrary transaction dan sebagainya. Okay, itu adalah core business layer. Okay, apa yang dia contain dalam library system. Okay, before go to the inner part of it, we call it database layer. Okay, database layer in terms of innermost database. Kat sini adalah banyaklah database yang ada. Okay, database yang ada. Mungkin adalah database, contoh kat sini database yang ada untuk IEEE. Okay, IEEE punya repository dia lain. Scopus repository dia lain. Contoh Web of Science repository dia lain. ACM repository dia lain dan sebagainya. Okay, so we have so many database and so on. So this is examples of the library system architecture using layered architecture. Library system using layered architecture. Kenapa saya boleh tahu adalah layered? Memang dia organize dalam layered. Okay, so same go to here adalah layered. Okay, layered. And then same go to here adalah layered. Maksud dia adalah presentation layered, logic area dengan data layered. Dia adalah layered dia. Maksud you kena identify lah. Ini adalah Amazon. Amazon adalah macam mana you adalah presentations untuk request ada protokol dan sebagainya, dapat layer dia untuk nak kepada kepada innermost data layer. Contoh untuk .NET. Ini adalah application architecture untuk .NET di mana kita ada presentation layer. Okay, ada UI, okay, user interface layer. So dia ada business layer, core business layer. Apa function dia yang ada. And then dia ada database layer. Okay, ada database layer and then dia ada foundation services. Dia boleh lukis kat tepi tu, foundation services untuk non-functional. Okay, untuk non-functional, untuk in terms of security dia macam mana, in terms of operational management dia macam mana, communication dia macam mana. So that is non-functional. Okay, dia lukis kat tepi ni. Okay, but this is a major layer yang ada. Okay, so what is the advantage macam saya kata? We support for incremental development. Contohnya dalam layer yang untuk core business layer ni, kalau saya nak tambah boleh tak? Boleh. Saya boleh tambah business layer, core services. Kalau selain daripada itu, saya boleh tambah function dia. So it's allowed for the incremental development. Okay? And it can be changeable. Dalam layer tu, kalau katakan saya nak tukar, jadikan lain, boleh tak? Boleh, tak ada masalah. As long as you comply to the interface between the adjacent layer with another layer. Maksud you kena pass parameter tu interface, kita namakan interface. Bukan user interface yang ada, adalah interface between component with the component. Okay, maksud passing parameters lah, guna technical terms adalah passing parameters. Kalau kita adalah interface, okay, bermaksud interface antara satu komponen dengan satu komponen, dia boleh passing the data and so on. Okay, but disadvantage ke sini adalah multiple layer tu akan cause the performance issue. Okay, and you have to punch in. Okay, katakan punch through almost many layer in order to get the service. So that is the only advantages yang ada. Dia in terms of performance memang out lah untuk layer architecture. Okay, untuk layer architecture. Okay, so far ada question tak before I
can we
continue?
combine
Ada
the
question ke?
Can we combine the MVC and the layer architecture into a single system, the single architecture?
Boleh. As I mentioned to you, boleh. Boleh untuk combination, boleh untuk combinations of architectures inside one architecture. Because but we have to actually comply to what the client needs and the logic of how you're going to combine it. Macam mana you nak lukiskan dalam satu diagram tu untuk combinations of the MVC dengan layer tu. So bermaksud dalam ni bermaksud core business layer dan sebagainya. Okay, bermaksud you akan ada punch through masih gunakan yang lain dan sebagainya, but untuk MVC tu bermaksud you kena adalah organize it into more different folder lah. Bermaksud different folder, and then at the same time you adalah gunakan untuk design tu adalah selain daripada web browser masuk, you ada user login masuk. Kalau kepada core business you kena request, and then kepada itu adalah kepada layer architecture design lah. Maksud how you going to draw it adalah dalam layer. Okay, dalam layer tak ada masalah. Cuma MVC is the patterns of writing the code. Jadikan dia organize, jadikan three major folder. Senang lah, ayat yang senang adalah three major folder. Kalau sesiapa yang terlibat dalam coding dia faham maksud saya. Maksud kalau biasa student buat lah, saya nampak student buat punya final year project.
Tapi sekarang ni ada limit.
Bila buka je sistem dia, semua lambat dalam satu folder, core system dia, FYP project. Kebanyakan kan namakan FYP project. Semua tu dia punya view dalam tu, controller dalam tu, and then kadang-kadang tak ada pun pembezaan. Bila dia nak maintain tu susah. Nak tukar dia punya attribute kat mana? Kena cari satu-satu. But if you organize it, you know that kalau ini adalah bahagian yang model, bermaksud semua melibatkan attribute data adalah kat situ. Dan senang kita nak maintain it. Okay? Right. Okay, we take a break around now my time showing is 9:25.
Ya, saya tengah kelas.
Yes, Doctor.
Okay. 10 minutes. Okay, 10 minutes kita akan balik 10
Okay. Around
9.35.
okay, sebab saya really
Take a break,
need back to my class.
Okay, thank you Doktor.
Waalaikumsalam warahmatullahi.
Boleh dengar? Okay, thank you. Okay, welcome back. Semua yang bekerja macam saya dah kot. Sabtu Ahad ya, kena kuatkan semangat ya.
Betul.
Betul Saya lebih baik sikit daripada you orang lah. Saya ada Ahad lagi untuk saya rehat. You orang Ahad pun kena kelas lagi ya. Right, can you see my screen?
Yes, Doktor.
Boleh nampak ke? Right, okay, thank you for the feedback. Right, let us continue. Okay, we only cover few very general architectures in this topic. So, but I would like to emphasize it's not limited to this application architecture only. Okay, kita hanya cover few things here, few application architectures here. So we have this one we talk about repository. When we have a repository, so meaning that we have a large amount of data that can be shared. Dalam keadaan yang kita ada data yang terlampau banyak kita nak guna. Okay, dalam to share. So that's why it is commonly used when you involve amount of data is huge. Contohnya yang kita guna pakai repository ni adalah students. Okay, students punya Oracle tu, Oracle gunakan repository. Okay, Oracle kita gunakan SIM Student Information Management System ni kita gunakan back end dia adalah gunakan Oracle. Oracle memang repository architecture. Okay, emphasize on the repository architecture. Okay, when we have a repository architecture, when you want to use it, when you have a large volume of information and data that you want to gather it and you want to store it for a very long time of usage. Maksud you nak guna pakai dia satu data yang besar dalam satu jangka masa yang agak panjang. Maka you have to actually consider for the repository architecture or repository patterns of it. Advantage, they do not need to know the existence of the other components. Ada komponen boleh wujud bila-bila masa, tak ada masalah. Data tu adalah data tu kita jaga data kita je. Bermaksud dia boleh anytime create any component to access the data, no problem. Okay, as long as you comply to the repository punya interface. You nak request data, dia ada protokol dia. Bermaksud you kena pandai untuk call dia punya interface untuk extracting the data and so on. Okay, so it actually can be managed consistently. Can ease for the backup sampai satu masa. Contoh, kita punya SIMs tu. Contoh macam UFuture lah. Kalau you log in kepada UFuture, dia punya interface beritahu pukul berapa ke pukul berapa dia akan adakan backup. Okay, bermaksud waktu tu jangan masuk lah. Waktu tu kalau you ada bermaksud kemungkinan sistem akan slow ke whatever. Contoh Maybank pun sama, Maybank to you. Dia adalah pukul berapa sampai pukul berapa dia adalah kepada backup. Maksud dia akan off kan untuk dia punya business processes dan sebagainya. Dia nak jalankan backup dan sebagainya. So backup is more easier, can be managed, can be consistently organized in one place. However, disadvantage there is actually a single point of failure. Meaning that once ada attack kepada contoh dia DOS, okay, denial of service attack. Once berlaku je, memang whole system akan affected. That's why kadang-kadang kebanyakan masa adalah repository dia akan menggunakan client server. Client server tu maksud repository disebabkan dia share data. At the same time disebabkan dia nak kepada availability. Okay, that's why dia kena juga adalah client server untuk redundancy tu berlaku. Okay, redundancy berlaku. So of course redundancy apabila berlaku memang security cost akan tinggi lah. Okay, security cost akan tinggi dan security concern akan lagi banyak. Maksud you kena secure banyak tempat yang ada. Okay, untuk elakkan kepada attack and so on. So that is actually the weakness of the repository because of a single point of failure. Okay, single point of failure. So this is the patterns of it. Okay, this is the patterns of it. So this is the repository in the tabular form. This is a pattern. For this one is actually for IDE. Okay, IDE. Maksud dia kalau you nak create satu language, okay, create satu compiler dan sebagainya, ini adalah repository architecture. Bermaksud you boleh ada design translator, project repository dan sebagainya, Java editor sebagainya. Okay, so ini adalah repository patterns. You have to know that, okay, each component is communicate with the center point that is a repository. Without knowing or without any communication between component with the component. Bermaksud Java editor, dia tak communicate dengan pattern editor. Dia tak ada connection ataupun any relationship pun. Dia hanya Java editor, dia akan ambil project repository, dia akan jalankan tugas dia, gunakan required daripada interface dia untuk jalankan tugas. Without knowing others component that connect to the repository, okay, to the shared data. Okay, dia tak kisah pun orang lain nak guna macam mana, as long as it's comply to the interface that request the data from the shared database. Okay, so this is another one, the repository pattern for ASP.NET. Okay, ASP.NET. So this is Oracle. Okay, repository for the Oracle. Bermaksud component and the component, you can still see that component dengan component ataupun dia punya modul dengan modul yang lain tu, dia tak communicate each other. No, it's actually communicating directly dengan repository. Once communicating directly dengan repository, dia kena comply dengan certain interface lah. Maksud you nak request data macam mana, okay, ada certain protocol nak ikut dan sebagainya. Okay, so this is for the Laravel. Okay, this is for the Laravel. That's actually you are getting the data, okay, from the data source, okay, from the data source and the repository. So this is a repository patterns in Laravel. Okay, so another one is a repository oriented game server. Maksud kita sekarang ni kan banyak melibatkan game kan, melibatkan game, online game. Contoh sekarang ni yang paling famous game apa? Saya rasa semua tahu kot. Among Us, pernah dengar?
Kena.
Taklah. Kena main tak?
Anak-anak main.
Okay. Anak-anak main, ibu tengok kat tepi dia. Okay. So memang famous lah sekarang ni. Contoh lah. So ini adalah repository oriented game server. Okay, repository oriented game server bermaksud dia ada satu tempat yang simpan semua benda. So if you have a large data, back to our basic. If you have a large volume of data, then you want to keep it in one place and use it for a long time, then repository architecture patterns is very important. Bila architecture patterns
Hello?
component actually does not have any relationship or any interaction between component dengan component. Jangan pula you letak satu line antara UML editor dengan code generator. Tak ada. Okay, you can see that the component actually didn't communicate between each other. Okay, so bermaksud yang ni itu yang paling penting lah, paling penting. Component dengan component. Okay, component dengan component dia akan kepada repository. So advantages of it, efficient for us to share a lot of amount of data. And then the subsystem do not have to generate their own database. Tak perlu, disebabkan dia dah keep in one centralized. Okay, for the backup, for the consistency. Maksud you nak refer satu tempat je. Refer satu tata, satu tempat je. Any modifications or any updates will be actually in one place. Okay, actually in one place. However, when it's in one place, then dia akan kepada single point failure. Okay, single point of failure. Meaning that kalau ada denial of service, DOS, attack and so on, it's going to make the whole system fail and so on. Okay, and then subsystem must agree on the repository data model. Bermaksud apa yang perlu pattern dia atau interface dia untuk nak fetch data. You kena comply lah. Kalau dia adalah gunakan certain data untuk interface, kita namakan interface. Contoh, kalau dia adalah data type, dia adalah data type, jenis data type apa you kena tahu untuk nak call, untuk nak guna, and then bila you nak save balik dalam bentuk macam mana dan sebagainya. In terms of that data model you kena tahu. So supaya you boleh communicate, okay, communicate dengan repository tersebut. Okay, and then it's difficult to be distribute efficiently. Okay, memang dia centralized. Memang susah. You nak distribute it. Okay, then we have another one that is client server. When we talk about client server, it's related to distribution. Bermaksud kalau you nak distribute, have a very different geographical area, and you want to actually use it in different place and so on, and you want to actually make it through request through server, clients, network and sebagainya, then you have to use the client server. When we talk about client server architectures, there's three major components that you have to put it inside your design. Number one is a stand-alone server. Dia maksud you kena ada server. Kedua, kena ada client. Contoh dia tu, client server. Mesti ada client, mesti ada server, and in between that will be a network. Tak kira you network apa, across the client to the server, to access the server, that will be the network. Sama ada you gunakan LAN, ataupun you guna WAN pun boleh, tak ada masalah. So in terms of network, to communicate in between the client, access the server. Okay, so and this is the tabular format. As I mentioned to you, client server patterns dia ada dua. Okay, pattern boleh view dia dalam dua. Satu adalah gunakan tabulate form. This is the tabulate format of it. When you use it, when you have a shared database that you want to access from various of location. Bermaksud data you ada satu, and then you nak kepada semua untuk access kepada data tersebut. Then you boleh fikir untuk client server. Okay, client server. Advantage of it actually is can be distributed across a network. Okay, across the network, and can be advantage for all the clients untuk guna pakai. Okay, guna pakai untuk satu service atau semua satu database yang sama. Disadvantage of it again is a single point of failure. May be unpredictable because it depends on network. Kalau network down, then out lah. Okay, network down, then it really depends on the network. Kalau network, katakan network provider, okay, service provider, hari tu down lah. Macam few days ago, Cellcom down. Bila Cellcom punya, I don't know lah, I don't know whether you using Cellcom or not. Kalau sesiapa yang using Cellcom, dia akan alami masalah tu lah. So bila once down, you akan affect kepada banyak benda. Okay, banyak benda yang ada lah. Oh, sorry sesiapa kalau kerja dengan Cellcom, bukan saya kutuk Cellcom, any telecommunication. Okay, any telecommunication. Honestly kat Malaysia tu kita quite, orang kata quite generous kot. Untuk contoh drop call, contoh network down, kita macam dah make it as a norm. Kata tak ada masalah, macam benda biasa lah, benda biasa. For your informations, my uncle kerja kat Singapura tu, dia sekarang ada PR kat Singapura. Actually, kat Singapura dia ada satu rule and regulation yang saya rasa kita boleh guna pakai. Every drop call, customers boleh minta compensation. Bermaksud minta ganti rugi. Every drop call. Bermaksud you telefon tiba hilang. Maka you boleh minta ganti rugi daripada telco tu. Any service down untuk berapa semua, klien boleh file for refund. Maksud you melibatkan kerugian apa-apa, you boleh file for refund. That's why kat sana dia punya network kena sentiasa tip-top. Okay, benda tu yang menjadikan dia memang jaga benda tu. Tapi kat Malaysia, oh memang sakit hati lah. Okay, saya rasa semua alami macam saya kot. Drop call perkara biasa, network down pun perkara biasa, semua biasalah tu.
Setuju doktor.
Betul kan? And then kita buat komplain, paling dahsyat tu kita buat komplain, buat don't know je. Aduh, memang lemah semangat. Okay, kita buat komplain, beritahu dan sebagainya, dia boleh, disebabkan dia klien ramai klien ramai, kalau you nak churn ke tempat lain, churn lah, tukar lah. Saya pun banyak klien lagi. Okay, I don't know lah. Ada certain telco tu menjadikan kita fed up. Kita terpaksa kena hukum dia dengan churn kepada benda lain. Okay, tukar kepada telco lain dan sebagainya. So this is the things that happens actually. This is the things that happens. Okay, this is an example. Example paling penting ada few dia punya, as I mentioned to you, 3 major components inside the client server architecture. Satu, very obvious of the clients, very obvious of the server, and also the network. Okay, the network that allow the client access to the server. Okay, ini adalah salah satu lah contoh client server. Ini salah satu contoh client server juga. Okay, di mana dia ada very clear cut of the client, very clear cut of the server, and satu adalah dia ada network tu. Network that allow the client to access the server. And then this is another example. This is another example is a lab. Okay, is a lab. Okay, internal gunakan wide area network in order to access. Okay, in order to access certain plants kat mana lah, kat west dengan east. Okay, kat mana dia nak access dan sebagainya. It is one of the server, client server. Dia ada very clear cut of the client, very clear cut of the server, and we have network. This is another example. Kita ada client, kita ada server, and then kita ada connection tu bermaksud internet tu. Internet ataupun network that allow the client to access the server. Okay, this all patterns ini adalah patterns yang ada untuk client server. Bermaksud kalau you kata contohlah macam saya kata tu dalam final assessment nanti, saya ada bagi satu senario, but senario saya tak akan beritahu you gunakan pattern mana ataupun sesuai guna architecture mana. It's up to you to design. When up to you to design, you have to make decision. Sama ada you nak guna repository, you nak gunakan client server, you nak gunakan pine filter, you nak gunakan layered, it's up to you. But once you guna katakan client server, make sure that 3 components tu penting. Saya nak nampak client server, client ada. Okay, clients kena ada, server kena ada, and then dia kena ada network tu. Okay, if you say you are using layered architecture design, make sure that you lukis tu dalam kek lapis tu, layered tu. Outermost adalah user interface layer, innermost mesti database. So benda tu adalah you kena comply lah. Maksud the generic patterns of it you have to comply. Faham Saya rasa semua berdebar kot. Kalau saya sebut je final assessment tu kena take note saya. Kalau saya sebut je final assessment tu, kerana final assessment soalan dia sikit je. Okay, soalan dia sikit je tapi perlukan masa. InsyaAllah you cari kat website pun tak jumpa. InsyaAllah cari kat website pun tak jumpa. Okay, kena untuk you fikir lah fikir macam mana you nak design. Boleh kot? Tak boleh pun kena boleh juga.
Okay, doktor.
40% kan doktor kan?
Kita kena
40% kan final assessment.
40% betul. 40%
Berapa soalan?
Saya tak decide lagi tapi saya akan cover topic 1, topic 2, topic 3 sampai topic 4 saja. Kalau topic 4. Topic 5 tu mungkin agile lah. Saya tak pasti lagi. Tapi setiap topik tu mesti ada soalan. And then you boleh pilih topik mana yang you nak ambil soalan tersebut. Okay, 40 markah. So 40 markah tu adalah differentiate you from the grade lah. Sama ada you layak you untuk dapat A+, A minus, B plus dengan B. You punya passing rate B You punya passing rate B. Sekiranya you dapat B minus, you have to repeat the subject. Okay, so that's why make sure that you really perform for the continuous assessment. 60 markah tu kalau boleh dapat 55, 50 ke atas lah. Okay, supaya dalam final assessment tu allow you to get a B, at least a B. Boleh? Is that sound terrible? Susah rasa macam susah challenge Honestly, saya tak pernah fail student lagi lah. Honestly saya tak pernah fail student lagi. Sebelum ni memang ramai akan fail. sebelum saya ada seorang lecturers, memang subjek ni memang selalu ada student fail. So setakat yang saya handle, I try to help the students because we need the students to have that knowledge. Okay, so in terms of learning, we want to teach the students to actually equip them with knowledge. We don't want the student to fail the subject kalau boleh, because it's involve money and cent. Maksud melibatkan dollar and cent untuk you register kepada masters. So I try to avoid it. But don't take it as advantage of you lah untuk kata Dr. Atika kata kebanyakan ada pass, then you simply hantar assignment dan sebagainya. No. If your assignment is not up to my standard, I will going to ask you to redo. Pernah student redo this assignment. Okay, redo the assignment. Okay, because you are in the master's level. If you doing the assignment, simply copy paste and so on. So I will going to actually easily detect it. Saya run plagiarism check je, turn it in. Saya dah tahu dah you ambil daripada source mana dan sebagainya. Kalau you tak tukar ayat semua akan tahu. Okay, that's why I ask you to send in soft copy so that I can run the turn it in order to know where is your sources. Okay, so back to our slide. Okay, back to our slide here. So this is the advantage of the advantage and disadvantage of client server. When we advantage, that means is a distribution. It needs you to distribute, okay, in different locational, geographical locations and so on. And it's very efficient for you to actually network and cheaper hardware. Disebabkan dia boleh share. Banyak service boleh share. For example, untuk printer, you boleh share. Contohlah, sekarang ni adalah jenis yang for the step machine. Kalau kat office kepada office automation dan sebagainya, kebiasaan gunakan printer sekarang ni adalah kepada for the step machine, jenis yang network. For the step machine jenis yang network ataupun printer jenis yang network. So masuk whole house, saya gunakan any device, duduk kat mana-mana, saya boleh networkkan kepada printer saya untuk print out something. So ataupun any for the step machine, gunakan local area network tu untuk connect to the printer. So it's actually everyone can use that for the step machine as a printer, as a scanner and so on. So actually it's going to cut down a lot of cost in terms of hardware. Okay, so that is the advantage of client server. Okay, this is the advantage of client server, especially for the office management. Okay, for the office management, you can actually cut down a lot of cost in terms of hardware. Okay, so easy for you if you have money, easy for you to add in. Kalau server tak cukup, beli server. Kalau katakan server place tak cukup, kalau sekarang ni kepada cloud, then you boleh untuk dapatkan cloud service dan sebagainya, cloud storage dan sebagainya. Okay, disadvantage of it is a no shared data model. So some system you're going to use different data organization. Okay, data organization bermaksud saya mungkin akan kepada kalau you tak ada shared model, dia akan saya keep data saya sendiri. Contohlah sistem UiTM, okay, SIM ada data dia sendiri. Lepas tu apabila kepada Prisma ada data dia sendiri. Staff ada data dia sendiri. Bermaksud semua bukan keep dalam Oracle yang repository tu. Tak. Maksud ada data yang berbeza. Okay, ada data. Kalau you future kat cloud. Okay, you future kat cloud. Okay, so benda-benda yang ni adalah disadvantage lah. Disadvantage of it. Okay, so the last one for the architecture, we call it pipe filter. Okay, pipe and filter. Pipe and filter actually is a very simple process. From the very beginning of the input, you have some process in between and you come up with the output, produce as output. In these kinds of thing, we call it pipe and filter. So meaning that we have a very clear cut of the input masuk, lalu certain process A, process B, process C dan sebagainya. So the input of one process will be the output for one another. The output for one process will be the input for another process and so on until you produce the end products of it. Okay, end products of it. That's why ini adalah nama dia sesuatu proses yang adalah. So in this kinds of system is not suitable for interactive system. Bermaksud interaktif bermaksud melibatkan user input. User input tak berapa sesuai untuk pipe and filter. Pipe and filter paling sesuai adalah contoh untuk data processing. Maksud you masuk je data sebagai input, dia akan mula proses, come out dengan output. Contoh billing system, contoh embedded system dan sebagainya. Paling sesuai untuk pipe and filter. Okay, this is the tabular descriptions of it. When you want to use it, commonly used for the data processing application. Okay, data processing applications. Bermaksud you adalah clear input, go through certain processes and come up with the outputs and so on. Okay, so easy to understand. Workflow type, kena ada workflow, ada business processes, very clear cut of it. Okay, so disadvantage of it actually the format of the data transfer. Karena saya kata output of one process will be the input for another process. That's why you kena agree upon the communication transformation or interface between the output and the input. Kalau output tu you kena comply dengan input another process lah, baru dia boleh continue. Once you disagree on the data, once you disagree on the communication transformations, then the process cannot continue. Okay, so this is the examples of it. It's a pipe filter. So dia ada invoice, read issue invoice. Invoice masa dah untuk baca, once baca dia identify payment. Sekiranya ada payment masuk, maka dia akan issue receipt. Sekiranya payment tak masuk, dia akan beritahu bila payment due dan dia akan keluar reminder. So dia akan hantar reminder kepada recipients dan sebagainya. This is the example. This is the example that process. Okay, process tu. Bermaksud benda tu adalah melibatkan satu business process. Okay. This is another example untuk sending email. Satu proses dengan satu proses, sending email. This is another process untuk cloud design. Dia untuk proses dia. Data source yang pertama, dia akan lalu proses. Ada banyak type task yang ada. Ya, bila macam tu, dia akan transform kepada data untuk masuk proses yang selainnya. Business logic yang lain lah. This is another one, pipe filter. This is another one untuk messaging channel. Okay, ini adalah patternnya. Maksud kalau you nak lukis sesuatu pipe filter tu, pipe and filter adalah jenis macam ada proses, clear cut of process. Okay, I think this will be almost, what will be the time now? 10. Okay, I have 45 minutes. Okay, any questions so far? Kita dah go through berapa very common one. So I hope when I talk about layer architecture, you dah tahu dah pattern, dia punya pattern macam mana. When I talk about repository architecture, you dah tahu dah pattern dia macam mana. When I talk about client server, you dah tahu dah macam mana. Pipe and filter, macam mana pattern dia. Okay, MVC, pattern dia macam mana. Okay, so if you can recall the pattern dan sebagainya, insyaAllah you faham lah kot berkaitan dengan apa tu architecture pattern. Okay, architecture pattern. And then architecture pattern boleh represented in two types. One is by the tabular form, the other one is the graphical representations. Okay, dua cara boleh untuk kepada pattern tu. Right? So here come to the generic application architecture. What is the generic application architecture? Is the things that we can directly reuse, okay, for application architecture to meet certain requirements of the client. Okay, so the use of the application architecture can be a starting point. That means if you don't have any idea, you can Google about it, and we have application architecture and you can modify on it. Itu yang nama dia generic application architecture. So it can be a design checklist. Apa yang included, apa tak included, what will be the things that you have to take care and how you're going to organize it. Kalau katakan untuk dalam development team, you kena plan kepada you punya Gantt chart dan sebagainya. Nak develop apa, bila nak develop, mana develop dulu dan sebagainya. Kira untuk dia punya dikira critical path. Critical path is a longest path and the shortest period of deliver the things. Maksud Kalau ini siap akan lalu kepada mana? Kalau ini siap adalah kepada mana? Kepada berapa hari perlukan dan sebagainya. Bila you kira untuk critical path tu, is the longest path but it's the shortest time for you to deliver the things. Okay, bermaksud you tahu dah mana yang importance. Kalau benda ni sangkut, you akan sangkut kepada whole project. So that's why ini adalah another knowledge lah yang saya tak cover dalam project management ni. Okay, dia adalah under project management. It's a bigger scope lagi. Siapa pernah dengar tak untuk critical path?
Benar doktor, saya baru bagi training untuk project management.
Share sikit. You guna apa untuk critical path tu? Guna method apa?
Saya guna Microsoft Project.
Microsoft Project.
Ya.
Okay, so you macam mana you kira untuk critical path tu? Mandates lah?
Ikut the business punya system lah. Kalau dia pakai days by days lah, kalau pakai hours by hours lah. Depending on the situation.
Okay, so definition untuk critical path tu adalah the longest path. Bermaksud the longest path, but this is the shortest time for you to complete. Maksud you dah identify what will be the critical component inside the whole process of development. Bila you kira, contoh you kira adalah perlukan adalah lebih kurang 60 hari. Okay, 60 hari tu mandates So bermaksud 60 hari itu adalah untuk nak siapkan projek tersebut. That will be your critical path tu. Bermaksud you kena ada kira sedikit untuk contingency. Okay, contingency 60 hari tu is a must untuk you habiskan satu projek tersebut. Maka you kena ada cushion lah, kita namakan cushion. Cushion tu adalah add few days. Add few days, sama ada cushion tu untuk setiap komponen ataupun cushion at the end. So it depends on the project manager nak buat lah. Dia boleh cushionkan plus one. Contoh katakan komponen yang pertama dia kira estimate 3 hari. Komponen yang kedua dia perlukan 4 hari. Komponen yang ketiga dia perlukan 5 hari dan sebagainya. If you add cushion to every part yang ada, bermaksud yang proses pertama you tambahkan 2 hari. Proses yang kedua you tambahkan sehari. Itu adalah add cushion. Add cushion to each part of it. Okay, each part of it. And then kalau satu lagi cara adalah at the end. Maksud you kira the whole things 60 hari you plus 5 days. Itu adalah cushion lah, letak kat situ supaya you dapat deliver and estimate what will be the deliver times or development times to give it to your company untuk deal dengan klien. Okay, so that's why that is the importance for you to identify the critical path yang ada. Betul Company you buat macam tu ke?
Tak semestinya doktor. Yang you cakap tu if the project is going as a linear project. Tapi kalau sometimes in project development two things will occur at the same time. So from Microsoft project we can see which one will produce a critical path.
Okay, that's why kena kira critical path tu. Okay, dia ada formula untuk nak kira tu critical path tu. Dia ada, saya tak ingat lah dia punya, ada gunakan PERT, P-E-R-T, PERT. Saya tak ingat lah dia punya formula. Dia ada formula untuk dia punya kiraan dia lah. Okay, that will be another knowledge. It is under dalam software project management. Okay, that will be the bigger part of it lah. Okay, so sepatutnya you punya master ni cover untuk sampai software project management. Tapi dia orang dah buang daripada syllabus. Okay. So disebabkan software project management adalah salah satu subjek yang you perlu ambil masa degree. Okay, perlu ambil masa degree. That's why kita orang dah take it out from the masters. Okay. Alright, so these are some example and again it's not limited to this one. Okay, kita ada data processing application. Dalam data processing application, what will be inside data processing? Transaction processing application, event processing dengan language processing. Let's have a look. Okay, so apabila application type ni, contoh adalah transaction processing system. Okay, contoh yang ni transaction processing system. Contoh ya, okay. Daripada I/O proses kepada application logic, kepada transaction manager, kepada database. Dia gunakan pattern apa?
Hide and filter.
Okay, good. Okay, pipe and filter. Okay, pipe and filter. Bermaksud walaupun ini adalah nama dia transaction processing application, dia adalah satu application architecture. Maksud dalam application, kalau you nak buat sesuatu transaction processing, contoh melibatkan penjualan, okay, melibatkan you punya satu sistem tu adalah nak untuk add to the cart dan sebagainya. Dia mesti ada input output proses. Bila macam tu you kena application logic tu kena ada, dan bila macam tu bila you nak bayar dia akan go for the transaction manager and then dia akan update dalam database. Sebelum database bagi feedback dah berjaya, transaction dah berjaya, dia akan kepada application logic akan outputkan kepada user dan sebagainya. Itu adalah pipe and filter pattern. However, this is follow the application architecture of transaction process. Maksud you nak create satu transaction process, these are the major component inside. Can you understand it? Boleh tak differentiate antara application architecture dengan pattern tadi tu? Boleh ke tak boleh?
What do you mean, Doktor?
So application, contoh macam ni adalah application architecture. Maksud transaction processing, ini adalah transaction. Kalau you nak design satu transaction process, ini adalah komponen yang ada. Boleh diguna pakai ataupun menambah baik kat sini. Maksud you kena confirm, kena ada input process, kena ada output process, kena ada application logic kat situ, maksud application function kat situ. Then you kena ada satu transaction manager. And then transaction manager kena deal dengan database yang ada. Ini adalah komponen yang perlu ada untuk sesuatu transaction process. Okay, cuma apabila transaction process ni dia guna pakai pipe filter. Boleh tak transaction process guna lain? Boleh, tak ada masalah. Contoh dia adalah guna ini lagi detail. Ini guna pipe and filter juga. Okay, pipe and filter, input, process, output, pipe and filter. What about, saya dah keluarkan what about this one? This one gunakan layer. Okay, saya dah keluarkan diagram. So actually melalui ini transaction process dia boleh guna lain, cara lain untuk nak design. Kalau gunakan layer boleh tak? Boleh, tak ada masalah. Ini adalah guna pakai pipe and filter. Okay. So another one is actually information system architecture. Ini adalah untuk transaction based. Okay, transaction based architecture. Okay, so this one gunakan transaction, gunakan information system architecture, gunakan layered. Maksud you ada user interface, you adalah authentications, you ada layer untuk user interface management. So you ada retrieval and then you ada transaction management. Okay, for example this one contohnya adalah mental health care patient management system. Satu adalah untuk patient management system. You ada web browser. So daripada web browser membolehkan user interface management, membolehkan user untuk login, melibatkan user boleh klik sama ada dia adalah patient ke, dia adalah nurse, dia adalah doktor, that's why role checking. Membolehkan dia request sesuatu benda, okay, that is a form and menu manager. And you adalah data validation, masukkan data betul ke tak, kalau melibatkan IC ada dash ke tak ada dash ke, and then IC tu boleh accept tak untuk kepada alphabet ke, itu adalah data validation. Kita namakan user interface management level.
Doktor, is this still the types of architecture for building a system or the application of the architecture?
Okay, it's actually this one we said it. This one we call it. We can actually, if you want to develop some patient management system, you boleh follow yang ni. But the architecture used here is a layer architecture. Boleh tak saya guna client server? Boleh, tak ada masalah. Okay, tapi komponen ni kena ada. Komponen yang ada tu bermaksud adalah contoh kalau you nak design design untuk layered, untuk information system, this is the layered yang you kena follow. Ini adalah nama dia sebagai application architecture. Maksud dalam application architecture yang guna pakai layered, you akan guna pakai yang ni. User interface kat luar, dalam tu kena ada user interface management, and then you kena ada satu core business or core services, and last sekali adalah database ataupun transaction manager. Okay, these are the application architecture. Contoh saya nak buat students information architecture system. Boleh guna pakai ni tak? Boleh. Kalau contoh saya nak buat tentang flight information architecture, boleh tak? Boleh. Tapi you kena detail out lah. Faham tak? Ini adalah application. You boleh follow.
So meaning this is still an architecture type lah.
Yes, this is still architecture. Still is application architecture. Application architecture. Okay. Belakang dia adalah layered. Dia gunakan layered. Okay, dia gunakan layered. Ini adalah satu information system. Tapi dia guna pakai pattern dia adalah layered. Ini adalah information system architecture. Tapi dia guna pakai pattern layered. Boleh faham ke? Information system.
Okay.
Dia adalah information system architecture, application architecture. Maksud kalau you nak buat sesuatu information system, tak kira lah you nak buat student information system, you nak buat staff information system, you nak buat library information system, you nak buat apa information system, ini adalah application architecture dia. Okay, you nak buat flight information system, contoh. You nak buat tentang library information system. Ini adalah application architecture dia. Cuma dia guna pakai kat sini adalah layered pattern. Okay? Dia gunakan layered pattern. Ini adalah contoh adalah patient management system. Information management system dia guna pakai layered. Okay? Dia guna pakai layered. Okay? Sama juga kalau satu katakan saya nak you design adalah untuk flight. Okay? Flight information system. Maka you boleh guna pakai information system ni, application ni boleh guna. Application architecture ni boleh guna. But you kena detail out dalam dia. Okay, you kena detail out dalam dia. At least 4 layer lah. First layer untuk user interface. Second layer tu kena ada user, melibatkan user communication tu. Masuk boleh untuk user login. Okay, login sebagai members. Ataupun login sebagai admin. Ataupun login sebagai agent. Travel agent. Okay, bermaksud dia adalah macam ni lah, role checking. Login, gunakan role checking, kena ada form dan menu, kena ada data validation. Bila masuk ke situ, baru function dia. Kalau function dia bermaksud, kalau melibatkan flight, adalah flight punya function lah. Kalau melibatkan ini adalah melibatkan patient management. Dia adalah more kepada patient punya, patient management system punya function, core service dia. Functionality of the application. Baru kepada patient database, flight database, library punya document database dan sebagainya. Boleh faham ke? Setakat ni?
So meaning right now we have 7 types of architecture lah.
Pattern dia basically dalam tadi tu, daripada tadi sampai sekarang pattern dia kita hanya introduce 5 pattern je. MVC, layered, client server, repository, pipe filter. Kita adalah 5 pattern. Tadi kita setakat kita introduce tadi adalah 5 pattern. Jadi application architecture tu bermaksud you boleh guna pakai, setakat ni saya tadi introduce hanya setakat kepada transaction, proses, okay. Kedua adalah information system, application tu. Ketiga nanti adalah language, okay, language. Ada lagi tak? Compiler, okay. Itu adalah application architecture. Bermaksud kalau sekiranya you nak create satu information system, ini adalah bentuk dia, application dia. Cuma dalam contoh ni dia gunakan layered pattern.
Okay, meaning how to apply the pattern to the system lah.
Correct. Okay. Sampai mana dah? Okay, yang ni adalah ini e-commerce. E-commerce saya tak bagi contoh sini . Ini adalah client server. Bermaksud kita boleh gunakan client server juga untuk information system. Maksud information system tu dia ada application architecture dia. But kita boleh gunakan layered, guna pakai web client server juga, tak ada masalah. Pattern tu kita boleh guna mana-mana. But application architecture tu dia identify komponen apa yang perlu ada sesuatu application. Okay, kalau information system, apa komponen dia dalam tu? Kalau transactions, processing, kena ada komponen apa dalam tu? Itu yang nama dia application architecture. Okay, bila you nak guna pakai, dia boleh guna pakai dalam pattern berbeza. Kalau depends on the design lah, you boleh guna pakai, guna pattern client server, boleh guna pakai pattern kepada repository dan sebagainya. Okay, nanti kita akan, rasanya nanti you akan lagi faham kot. Untuk language processing, ini adalah untuk language processing punya application architecture. Application architecture bermaksud sesuatu language process, dia kena ada translator. Okay, dia kena ada source language, dia kena ada translator, dia kena ada abstract, dia kena ada interpreters. Okay, ini adalah language processing system. Maksud sesuatu language processing, contohlah you nak buat interpreters, contohlah you nak buat tentang compiler. Ini adalah satu application architecture yang you boleh guna. Okay, cuma yang ni adalah compiler components. Ini adalah komponen ini perlu ada untuk sesuatu compiler. Ini yang nama dia application architecture. Dia kenal pasti komponen apa yang perlu dalam sesuatu application. Tetapi nak guna pattern apa? Dia boleh guna pakai pattern pipe filter. Boleh guna pattern repository. Faham tak?
Faham Doktor?
Okay. So bermaksud dua benda yang berbeza. Application architecture hanya identify komponen apa. Contoh yang ni application architecture. Maksud dia hanya identify komponen apa. Okay, komponen apa? Komponen apa kalau saya nak buat sesuatu compiler? Dia kena ada lexicon analyzer. Dia kena ada symbol table. Dia kena ada syntax analyzer. Dia kena ada syntax tree. Dia kena semantic analyzer dengan satu code generator. Adalah 6 komponen ni adalah make out satu application architecture. Bermaksud you kata saya nak create satu compiler lah. Bermaksud these are the 6 basic component that you should have in an application architecture if you want to design a compiler. But how you're going to design it is back to the considerations untuk non-functional ke dan sebagainya. The decision just now. Ini adalah design it with a pipe filter. Guna cara pipe filter. Maksud komponen dia kena ada. Contoh macam tadi tu lexicon, symbol, analyzer dan sebagainya dia kena ada. Okay, kena ada. Cuma kita dah translate it into pipe filter pattern dia. Okay, pattern dia. So application dia yang ni, application architecture dia kena ada komponen ni. But kita boleh design dia gunakan pipe filter. Gunakan pipe filter, maksud lexicon analysis, kena ada symbol table, check for the symbol table dan sebagainya. So and then dia ada syntax tree. Kita kena syntactic analysis. Go through, check syntax dan sebagainya and then go through, check semantic. Bila dapat check semantic dan sebagainya, baru you boleh generating code dan sebagainya. So bila generating code, you kena check balik simbol betul ke tak dan sebagainya. Ini adalah pipe filter compiler architecture. But komponen dia sama. Let's say this one pun sama. This one adalah tapi ini dalam design repository. Dalam design repository. Bermaksud dia kena ada komponen ni. Bermaksud ini adalah bukan solid kepada yang komponen tadi dia ada tambahan. Tapi basic untuk application komponen tu dia ada. Okay. Bermaksud dia ada symbol table, syntax tree, ada analyzer, ada semantic analyzer, semua yang komponen yang ada dalam application architecture dia ada. But it's organized into repository architecture. Can you get me? Setakat ni boleh tak untuk faham dua benda yang berbeza?
Faham.
Faham Okay. If you want to actually design it as a repository, ini adalah repository pattern. When we have a repository pattern, kita tahu tengah-tengah tu adalah repository. And then apabila dia draw design ni, dia tak ada communication antara komponen dengan komponen. Okay, itu yang beza dia. Okay, beza dia bila repository you kata you guna pakai repository architecture, make sure that dia tak ada communication in between component with the component. It's only communicate through the repository. Okay, so what is the time now? Okay, I quickly go through two things. Yang ni saya akan cover dalam next week. Next week punya I discuss, saya akan cuba keluarkan satu exercise ataupun soalan membolehkan you buat use case. Okay, satu soalan membolehkan you buat use case diagram. Okay, use case diagram dengan contoh kepada use case description. Okay, ini saya akan cover next week dalam I discuss. Okay, right, I would like to emphasize this one. Okay. Okay, so whenever we have design, no matter how is the design dan sebagainya, okay, focus here when it's have an implementation. This is the common three implementation issue. Okay, highlight this slide. Highlight this slide. Three common implementation issues that you have to actually regardless of what will be the design. Okay, what will be the system that you want to develop? These are three common issues. One is reuse. Okay, one is reuse issue. Most of the modern software is constructed by reusing the existing components. Okay, when you reuse existing components dan sebagainya, make sure that you really check for the details for the reuse. Sama ada dia compatible or not. Because some of the reuse issue, when you reuse it, you have to thorough check on it. Otherwise, you are going to face a problem when you actually really put it into implementation. Disebabkan you beranggapan benda ni pernah run, pernah guna, tak ada masalah. Apabila you guna, you tak test it thoroughly. So that is the issue of the implementation. Because we have the mindset that we can reuse the component, and in our past experience, the components actually perform really well, no errors at all and so on. We tend to neglect the thorough check on it. So that is the implementation issue. Bila you guna pakai reuse concept dan sebagainya, make sure you really check the compatible of the reuse component and the current component, whether it is compatible or not, whether it have some issue occur or not, and you still have to conduct a thorough test on it. Okay, that is the first reuse implementation issue related to reuse. Second is a configuration management. Okay, when you have a component-based software development, okay, component-based software development, let's say now you are using some very simple web applications architecture in order to quickly build out your website. Okay, bermaksud you akan gunakan banyak komponen yang ada. Contoh you gunakan Laravel dan sebagainya untuk build out komponen, ataupun you gunakan Ionic framework untuk build out the component quickly. Adalah guna drag and drop dan sebagainya. Semua adalah component based development. Once you have a component based development, and you have to actually really manage on the configurations of it. Version mana you guna, so daripada source mana you guna, berapa mana duration so component tu akan expired, what will be the update versions of the component, have to manage it and so on. If you didn't care about it, that will be actually your client will be facing an implementation issue later. Juga kebanyakan ada certain website agent, honestly untuk government agency, actually dululah gunakan jumlah. Okay, gunakan jumlah, quickly build out everything dan sebagainya. Memang cantik, layout cantik, orang pun puas hati dan sebagainya. But have a configuration management issue later on. Why? Certain komponen tak boleh muncul, keluar ada satu petak cross, maksud image cannot be displayed. Ataupun komponen tak boleh nak run, komponen untuk kalender tak boleh nak run, komponen untuk feedback tak boleh nak run dan sebagainya. So that is the things of the implementation issue that you have to take care. Okay, kalau you gunakan certain framework, you can quickly build on it. However, please pay attention to the configuration or version issue yang ada. Okay. The third one that we would like to emphasize is the host target development. When it's have, especially when the production software actually does not usually execute on the same computers of the software development environment. Kebiasaan kita gunakan local host. Masa develop kita gunakan local host untuk passing the data, untuk gunakan untuk kepada untuk processing dan sebagainya. It's run well inside the local host dan sebagainya. But when it put into life, maksud letak dalam target system. Okay, target system when really want to run it. So that's why kadang-kadang most of the developers yang melibatkan, dia kata nak go live je, dia kena standby. Dia kena ada team dia standby, go live je, dia kena tengok sebelum tu dia actually dah banyak kali testing dah. Banyak kali testing untuk letak kat server, untuk run dan sebagainya. But bila go live, memang whole thing tu memang orang kata dia punya level attention tu memang high lah. Kena standby, anything can happen. Okay, anything can happen. That is actually the implementation issue. Anyone ada experience tak untuk nak kepada you punya website ke whatever product so nak go live?
Benar, Doktor.
Okay, boleh experience, boleh ceritakan sikit tak?
Usually the host target development lah. Sebab kita develop it on our own PC. So our PC have the latest version of PHP, all the requirements lah. But when we want to make it in the production server is outdated.
Okay. Especially for the client side. Okay, of the client side, and then tak compatible dengan apa yang kita dah design dan sebagainya. So that is actually the issue lah on the implementation that we have to take care. Okay, you have to take care. So whoever have the experience, working experience dan sebagainya. So during the final assessment, because the question is quite open. It's good that you have experience and you have to put your example inside the answer. That will actually is a value added. Based on your experience, you explained it and so on. That will be advantage of you that whoever ada working experience dalam final assessment dan sebagainya. Because I would like to design the questions. They have two type of questions. Satu adalah jenis yang tak ada working experience, yang boleh jawab soalan tu. Jenis yang satu adalah working experience yang tak ada masa membaca, tapi dia masih boleh menjawab. I would like to design that kinds of final assessment supaya is a win-win situation. Sesiapa yang tak ada working experience, dia still boleh jawab, pilih soalan yang boleh dia jawab. Sesiapa yang ada working experience, dia boleh pilih soalan yang jenis open-ended, yang dia boleh share the experience inside the answer, then can get the marks and so on. So that kinds of final assessment akan keluar. Don't worry, I will cater for both parties yang ada. Okay, disebabkan saya tahu we have different types group yang students. Okay, ada yang ada kerja lagi dengan family lagi dan sebagainya. Bergantung kepada dia nak baca, memang out lah. Tapi untuk kalau saya keluarkan soalan yang jenis open-ended, dia boleh jawab gunakan experience dia. Okay, it's okay, no problem at all. Okay, is that okay? Setuju kot? Soalan jenis macam tu, win-win situation kot?
Setuju.
Okay, so detail part you can actually read on it. Saya ada few slide dalam this detail part. Okay, I quickly go through. This will be the last one. The last two slides yang ada untuk related to today topic. So again, today topic and next week topic is supposed to be recovers about design and implementation. But this week topic, I will go into actually the colored one is the slide that I highlight during my lecture, the online lecture. But detail part you can read on it. Okay. So it's actually I think it's quite my slide in your future is quite detailed. You can read on it, and if you need some reading, you just have to Google about it. Okay. Sometimes I taking something from the internet. Right. So The last topic for topic design and development is related to the open source development. Okay, we cannot deny that this is one of the popular approach right now in most of the software house, open source development. Okay, is a source code that actually being published and volunteers are invited. Contoh GitHub. Okay, so kalau contoh ada apa-apa yang you perlu develop dan sebagainya, you try to find actually the codes that's available outside. Okay, that is a common, orang kata tak salah, tak ada masalah. But you have to bear in mind that the codes that you download belongs to open source and still belong to the owner of the codes yang ada. So you still, walaupun dia kata adalah free software foundation, however you still bind to certain license and rules and regulations yang ada before you can commercialize it. Okay, before you can commercialize it. So open source development is a choice. Why? Because the logic behind it is it have large populations of volunteers developers contributing to the codes and make the actually extension to the code and so on. Okay, extension to the codes. That's why most of the software house nak cut down cost dan sebagainya. That's why just now dia pun mention PHP, MySQL, Java dan sebagainya. So this is the things that we call it actually is open source and you can use it. Okay, you can use it. Java, so Apache website dengan MySQL, PHP dan sebagainya. The benefit of it actually is a mature open source system. Okay, so bugs actually can be discovered and can be repaired compared to any of the proprietary software. That means any purchase software, contoh kalau katakan Microsoft Office ada problem dan sebagainya, you nak suruh dia fix akan ambil masa yang lama dan sebagainya, tunggu sampai next version baru boleh fix dan sebagainya. But untuk open source, if you send in your comment saying that okay, I run this code, we have some bugs here and so on, try to fix it. Actually is a lot of developers volunteers in order to fix it for you. Dia akan bagi suggestion, cuba yang ni, cuba extension ni, and then you can actually try and error and that one. And then actually it's going to cut down a lot of costs, especially for the small business company. Small business punya software house, bila dia nak cut down cost, dia tak boleh nak gunakan contoh Oracle memang stable tapi mahal sangat license dia. So that's why kita masih stick to, kalau katakan nak cut down the cost untuk maintenance wise pun senang sikit, untuk nanti cost efektif kepada client, you akan still gunakan MySQL sebagai choice dan sebagainya. So that is the things that make the open source quite popular. The things here actually is the licensing. These are some licensing model yang ada. Bermaksud masih ada licensing. I would like to highlight that walaupun dia adalah open source, walaupun dia adalah free software under free software foundation, but it still have certain licensing yang ada. Licensing ada. Kalau you kata licensing nak kepada commercialize, okay, commercialize dan sebagainya, dia akan guna pakai yang paling last sekali itu. Actually you some sort of actually use the commercial products yang ada. Okay, and actually have to contact to the owner. Okay, have some, kadang-kadang dia akan suruh you contribute. Okay, contribute to the code, baru you boleh ambil guna code tersebut untuk commercialize dan sebagainya. It depends on it. So ini adalah some license punya contoh lah. Okay. So I think that's all. That's all for today's lecture. Okay. Okay. Any questions so far? Okay, saya nak follow up tentang again next week tak ada kelas sesiapa yang join lambat tadi. Okay, I actually in the early of the lecture I make the announcement saying that next week 14th of November actually we don't have any class because of a public holiday. However, I'm going to post questions in I discuss dalam you future tu kalau you log in kepada you future dia ada satu option kat sebelah kiri tu ada satu option dia nama dia I discuss. I will going to post questions, okay? I think one or two questions there. So I will going to make it one lah. Satu je lah questions. Please read through and give your answer. Directly reply. Directly reply to the topics so that I know who is actually participants and who is actually reading and giving an answer. Okay, make sure that you participate in the replying to the questions. Okay, that will be your attendance for the ODL. Okay, online distance learnings for next week. So you will I will going to post the questions on 14. Okay, on 14th of November, and due date for you to answer is before 21st. 1 week time lah. You have ample time. Malam-malam kalau ada masa, tolong baca, jawab soalan dan sebagainya. I will going to make it only one question. So make sure you answer, reply to it. Make sure it's the attendance that will record the attendance for 14th of November. Okay.
Doktor, dia based on topic today ke?
Yes, topic, no, topic today adalah more kepada design and implementation tadi itu. Untuk kepada use case. Satu design question berkaitan dengan use case. Okay, saya akan bagi you scenario. So, you akan cuba lukis use case. Sama ada you gunakan hand drawing ke, kalau sesiapa yang tak familiar. Ataupun you boleh download Star UML. Ataupun you boleh
Ya betul.
gunakan
Nur Aisyah binti Zakaria. Tanasiah binti Bakar.
Doktor, putus-putus doktor.
Kalau tak siap saya sama typing. Typing.
Hello, Doctor.
main Tunggu kejap boleh? Boleh dengar tak?
Sekarang baru boleh dengar.
Okay. Alright. Sorry. So I just want to follow up about your assessment one. Do you have any problem so far? Assessment one akan due next week ya? So far ada problem tak? Can I have feedback?
So far no problem, just some issue on the terms for the requirement management. Okay, when I try to find some readings lah, some papers on the requirement management, most of it indicates that the whole process is a requirement management. The whole requirement engineering process is a requirement management. So basically, when you teach us, the requirement management is more about the changes in the requirement, right?
Okay. Actually, the terminology, somehow terminology, as I mentioned to you, some researcher we're going to actually using some different terminology in turn to define. So it's up to you actually to analyze it and then try to present it according to your understanding. So basically, whatever I share here is referring to a generic. Here it refer to the generic terminology used in the software engineering. actually the difference between the terminology used in the papers and so on. As long as you see synthesize it and group it and put it as a point, okay, point of view. Group it paling penting adalah group it. Group it, contoh you kata untuk in terms of requirement engineering. Requirement engineering adalah whole process. Kalau you nak katakan you cerita tentang elicitation saja, boleh tak? Boleh, tak ada masalah. Kalau you kata kepada requirement analysis, boleh tak? Tak ada masalah. Contoh Nazim kata adalah dia nak muka pada requirement management, boleh tak? Tak ada masalah. As long as it belong to the requirement engineering punya process, is acceptable. Okay, is acceptable. As long as dia adalah berkaitan dengan requirement engineering and at the same time is related to how you gather the requirement for a mobile application development. Boleh assignment tu is quite open lah. Dia tak ada kata very specific untuk you kena buat the whole process of requirement engineering, tak ada. Okay, tak perlu. Okay, tak perlu. If you emphasize only on the elicitations, masuk masa untuk requirement gathering for the mobile application development, boleh tak? Boleh, tak ada masalah. Okay, anything else to ask before I end out the class? Because you have to attend another class, right? Ada apa-apa soalan lagi tak? Before we end out the class. Okay, sesiapa yang tak log in melalui future, make sure that you type your name and matrix number. Okay, whoever didn't log in from your future, please write down your name and matrix number in the chat room. Okay. Okay, last, ada question lagi tak sebelum kita end out the session? Tak ada Okay, right, good. Okay, kalau tak ada, so that's all for today. So we are going to actually take 1 week, 2 weeks, nearly more than 1 week in order for us to meet again. We are going to actually have class on the 21st, have online class on the 21st of November nanti. Okay, that's all for today. And
Betul. Doktor kata deadline untuk assignment 1 is next week.
21st kan? Bukan?
Next week 14 kan?
Next week 14
Next week 14.
Okay. I think it's 21st Saya tak ingat.
You gave us
22nd.
until 22nd.
Okay, alright. Thank you Nazim for the clarification. So 22nd lah. Terkejut lah Nazim Jantung tak terkeluar je. Jantung keluar masuk balik Okay, 22 Saya dah set dalam link dan saya dah set dalam website. Okay, that's all for today. Thank you very much and we meet again on the 21st of November. Okay, see you then. Okay, Assalamualaikum.
Thank you, Doktor. Thank you, Doktor.
Wassalam. Thank you, Doctor.
Thank you.
Thank you, Doctor. Thank you, Doctor.
Right.
Thank you, Doctor.
Right.